What excites me about engineering? I'm thinking.
I've just grown up doing it. Probably like many engineers, watching Star Trek as a kid, seeing Scotty, save the day on many occasions. Like, I want to do that.
I really enjoy designing and creating things. Having all of these tools available to me to create things is just endless amounts of, colors in your palette.
Just the building and designing and figuring out how everything goes together, where it's supposed to be, how it's supposed to work, it lives within me.
Create something that makes people's lives in some way, shape, or form better.
Watching something come from on a piece of paper to something you put in your hand, and just be amazed that it actually works.
For me, engineering brings technology together to make useful products that can benefit people's lives.
This problem-solving thought process that it permeates everything I do, and I think most engineers have a similar story. It was an early experience for them where they realized that they wanted to be a problem solver and or a creator of things that can affect people's lives. And it could be weeks, it could be months, it could be years. I think most engineers have an example in their careers when they realize that their job is really not that anymore.
Everybody. So show of hands, how many people cheated and watched the YouTube recording of this keynote already? You guys are liars. Just 2 of you? Well, if you did, we added a wrinkle, so it's going to be slightly different. And that one of those wrinkles was we got up and we did a dry run very early this morning. We had some technical difficulties, and then it didn't work. And we can't for the life of us figure out why we had a bad connection somewhere. That's really what it looks like. So back to the keynote. So look, the purpose of the video is it's something I've been talking about for years, which is none of us, I think, are here by accident. Now, rarely have I ever heard anybody say, well, I became an engineer because I don't know why. But I know a lot of people that have other jobs that say, well, I just sort of fell into it. And for most of us, this was a pursuit, something that happened at a very early age, and that's obviously the point of the video. For me, as I said last night, it was my father exposing me. He brought home a dirt bike, and it didn't work, and we took it apart. And he was an engineer, and then we got into cars, and then I got into electronics. And so it was a sort of emotional journey that I went through. And I remember vividly the first time I built something that actually was used by the public at large. And when it came on and seeing it, it was like this emotional response. And I still do this to this day. When I build something, I build things around my house, motorcycles, cars, as I said, and I actually sort of touch it, and it's sort of alive to me. But when I then got my first job, it became obvious to me that, shoot, only like half of my job was actually designing and creating really cool stuff. A lot of it was just dealing with this other stuff. And the industry is sort of at odds with all of your sort of passion and compulsion to create. So what we'll do is we'll just sort of step through some of those trends, and then we'll jump into Altium Designer 20, and then we'll show you Altium Concord Pro running on our cloud platform, Altium 365. Now, some of those trends are as follows. So firstly, this accelerated time to market. When I first got my first design job, it was in the audio space. And we spent a year developing a power amplifier. We must have gone through 100 different toroidal transformers, listening to these different toroidal transformers, matching transistors, so on and so forth. But we took a year to develop a power amp. And, that's not rocket science. my passion was always to be in engineering, but then ultimately to be in business. So shortly thereafter, I got into the semiconductor business, and I was selling Xilinx components, FPGA, CPLDs, that sort of thing. And when I got the job, I remember vividly showing up, and I had my J.C. Penney suit that I borrowed some money from a friend to buy. And they said, well, there's your desk, there's your chair, there's your phone, there's the phone book, have a ball, but you're not going to make a penny for 2 years. And I said, well, why not? He says, well, customer design cycle's 2 years. And oh, by the way, 90% of the designs you work on with these customers of yours will never see the light of day. And that absolutely held true. It was almost 2 years to the day that I started making some commission dollars on those designs. Well, if we look at today, that design cycle has accelerated tremendously. And this is the number one thing we hear from customers, stating that they just don't have time to do the things they want to do. In fact, Carl talked about this yesterday, with the manager coming to him and says, well, it's routed, let's ship it. These are some statistics that we've collected from our user base. And if you look at what's happening now, 74% of you guys are designing at least 10 printed circuit boards a year, and 42% are designing at least 25. And if we look at that in terms of time, like Rick talks about, we should always design to time and not length. You can see the average design cycle on 80% is less than 6 months. So this is a tremendous amount of pressure that's being applied to all of us in this room that's at odds with the thing you really enjoy, indulging your passion, which is designing and creating really cool things. Now, another thing that we see happening is this growing complexity. And that's the growing complexity not just of the designs themselves, which in fact they are getting more complex. As an example, I've seen DDR2 memory on a vacuum cleaner. And who would have thought that? But not only that, but more and more of the peripheral processes are being put on all of us in this room. When I was selling Xilinx, they were keen to talk to me. Engineers would happily have me, and we brought engineering resources. But because they had a 2-year design cycle and because of Moore's Law, they wanted to see where we were. But as a salesperson, I would absolutely want to say, well, let's talk about power regulation. Let's talk about discrete logic. Let's talk about all those other things that are non-proprietary. And they always said the same thing. Talk to the buyer. Talk to the buyer. I'm not interested in that stuff. But now you guys are all tasked with doing that on the front end. You're having to do the sourcing. You're having to choose suppliers. You're having to negotiate pricing, get price breaks, all that sort of stuff. And what that's leading to is, in addition to that, I should say, is as the design complexities have increased, the engineers have had to assume the printed circuit board design responsibilities, and the PCB designers have also had to become engineers in their own right. So show of hands in the room here, how many of you are electrical engineers? It's most of you. Most of you. And here's some statistics to sort of back that up, again from the same survey. So 10 years ago, a gig data rate was pretty substantial, but now we see designs 28 gig, 40 gig pretty regularly. And when surveyed, half of you guys say that you have at least a data rate of a gig. And when surveyed, only 14% of you guys identify as PCB designers. The rest of our customers are in fact electrical engineers. And what that's leading to now is this concept, which is when PCB design was a specialty, they were very tight and very close to the manufacturing and the fabrication. They had a deep understanding of the manufacturing and fabrication process. But as that has been assumed by the electrical engineers, there's a growing divide. So show of hands in the room, how many of you have visited your PCB fabricator? That's much better than we saw in San Diego. How many people have visited your EMS supplier? Less. So what we tried to fill this hole with design for manufacture, design for manufacture, design for manufacture. And that's been in vogue since my career's been running, which is a better part of 20 years now. Yet, when we talk to the PCB fabricators, the EMS manufacturers, they say, I ask them, how many of your designs go on hold when they hit your desk to be manufactured? The most common response is all of them. Absolutely all of them. How many people in this room, show of hands, have had the experience with all of your designs going on hold for whatever reason when they hit the manufacturer? 75% of them? You guys are liars. 75%. How many people have at least 75% of their designs go on hold when they go to be manufactured? All right, prove me wrong. Mike's the only honest one in the room. Now, as we've evolved, or I should say emerged as the #1 player in this market space, as I've been saying to you guys all week, we have really consciously made an effort to focus on the user. But as we've become #1, there's now an even stronger imperative that our entire organization focus on the user. And I mean the entire organization. And so what you'll see is not just our marketing, not just our sales, but a complete pivot of our entire organization, pivoting to this user-centric approach to how we do things. And some of these things, and we'll come back to this in just a few minutes, some of these things you would have already noticed. We'll show you some developments in Altium Designer 20 that we did in concert with all of you guys. But when we talk about how we engage with you on our forums, how we engage with you on our bug crunch, how we engage with you on our ideas forum, you will begin to see marked differences in how we engage with all of you guys there. And AltiumLive is yet another example of this user centricity that we're trying to put forward. And it's obviously a face-to-face live manifestation of this user-centric approach. All right, so what we're going to do now is we're going to bring up a couple gentlemen, and we're going to walk you through Altium Designer 20. And then we're going to bring up another gentleman in just a minute and some other people from around the world and walk you through Altium Concord Pro running on Altium 365. So if I could, bring in Mr. Ben Jordan.
Good morning.
And then Christian Keller. So many of you probably recognize Ben's face. I'm certainly sure you recognize his voice. He's definitely the voice of most of our video content. And Christian would be our sort of German Ben Jordan, if you will. All right, so as we go through this, and if we could bring up the monitors, we're good? All right, thank you. So over here on this side, Ben's going to be walking us through the current experience, or the experience you might be more familiar with, currently running in Altium 19.
19.1.5.
And Christian over here is going to show us the new experience that you should expect, or will expect, in Altium Designer 20. Okay? So we'll start sort of slow and subtle, and then we'll work to the crescendo, as it were. As I said, we've taken this very user-centric approach, and the first thing we want to talk through is something that is used quite often. It's something that we changed fairly drastically in Altium Designer 18 when we went to the new user interface. And what we discovered was that new people coming to Altium Designer, evaluating the product, love this capability, love the new look and feel of this particular experience. But we got some feedback. And now that feedback, Ben, is about the properties panel.
That's correct.
So what did you hear from our users about the properties panel?
Yes. So how many of you have actually used Altium Designer since, say, version 6 or 7? There was no 7. That's a trick. Yeah. We went from 6 to summer 08, anyway. You've all known this very useful tool, and if you don't, you should go and research it because it's very powerful. It used to be called the inspector panel. And so I can, where's my mouse? Here we are. I can do editing of common objects. So if I select all these net labels on the schematic, I can see their common attributes. So in Altium Designer 18, this was renamed properties because the idea was to simplify, follow the advice of the great Albert Einstein, keep things as simple as possible, but no simpler. And so we removed modal dialogues. When you double-click on an item, like a schematic symbol, instead of opening a dialog in front of your schematic, it highlights that object and puts you over in the properties panel on the side where you can edit any of the attributes of that. You can look at what footprints are attached, 2D, 3D. Everything you need is there, and the component parameters, the pin lists, it's all there. And if you select multiple objects, you can edit all those common attributes at the same time. And we also added this really neat selection filter, which had been missing in Altium tools earlier than version 18.
So Ben, I think that's all well and good, but what was the sort of feedback that the existing users, our power users gave us when we made these changes?
That's just the thing. So this is really powerful, but I don't know about you, but for me personally, I like to double click on an object and have a dialog appear so I can just edit, click OK, and keep working. So if you're editing one thing, we're diverting your attention to the side. And so many people said, hey, bring back the modal dialogues.
So this is a subtle enhancement or change, which we're going to have Christian walk through in just a second. But it struck me quite sharply in San Diego. I was talking to one of our users at Microchip. And he came up to me and said, hey, how you doing, Lawrence? What's going on? I said, well, how are you getting on with the product? How are things going? He's like, look, we love the product. It's great, but quit hiding the cheese. And what he meant to say was, if it ain't broke, don't fix it. Okay, so we got with the user community and we made some changes. And Christian, what does that new experience look like?
Well, the new experience is the old experience. So you do a double click on it and you'll get back this window style thing, exactly what Ben told us, having everything in one more compact view a little bit. And if you're done, you can get rid of it by closing it again. So getting back this old thing. But we keep the new thing as well. There has been some overwork done, that you get more possibilities to adjust things in this view, getting rid, of course, for example, of the graphics, things like this. And when we have a view to the PCB world, we will see that we do get additional information here as well. So in both worlds, for example, in PCB, we get the board density right now. So we can see how much space is used on our board, so following IPC norms, medium, narrow, large, things like this. We get information right now directly inside the tool to see where are we.
So also, Christian, when we talk about subtleties and subtle enhancements to the product, on the schematic side, we've made some changes as well, which really kind of sets us up for the future. Can you talk us through that change?
You're talking of the graphical things?
Correct.
The graphical things, so building up a screen needs some time if a program does it, except you're getting some slave doing it for you. And in PCB world, we use DirectX to speed up everything, to have smoothened zoom in, zoom out, pushing, shoving, all those things. And we get this in schematic as well. So even or especially for bigger designs, so having not a 4-piece of schematic, but we have customers having a 0 as a piece of schematic. And of course, there's an immense amount of information on it, and this will get much, much faster with Altium Designer 20.
And so what does this mean for the future? What does this set us up to do?
Well, I think I'm not allowed to talk about those things. No, I will not.
So this next topic we want to talk about is something that we've focused on for many years, and it's something that I was intimately involved in when I first started at Altium. That's this unified environment, this unified data model. It's something that we're quite famous for. So when we talk to existing users, it's still the #1 thing they state as, this is why we love Altium Designer. It's this unified design environment, this unified data model. And that was front and center in our marketing for many, many years. And we sort of backed off of it, at least from a public-facing standpoint. We don't talk about it too much anymore. And I think it just, quite frankly, has a lot to do with us. We just kind of maybe got tired of talking about it, but the users and the prospect users still love it. Another piece to this is that, for the most part, all of our competitors have appropriated that message. I mean, in identical words. And what we're saying now is, well, we're going to take that back. Unified design is ours, and what I like to say is our competitors are unified in name only. And as part of that, we're making some subtle changes to the unified environment and making that a dynamic, unified environment. But Ben, if you could just remind everybody about this current experience in Altium Designer 19.
Yeah, so as most of you would probably think of when you say unified environment, you're thinking the user interface in schematic and PCB is basically the same. You have the same set of common shortcut keys and operations, but we also have that unified data model. So that means from the library, when I place a component, I have everything I need to implement that physically on the board as well. It's not just a symbol disconnected from some footprint library down the hall that may be wrong. Everything's together in one place. Correct 2D footprint, 3D, it's all there. Now, one thing that is still a little bit disjointed is in Altium Designer up to this point, to build that flat, take your hierarchical schematics and build that into a flat net list that's physically realizable on the PCB. We still have to compile the design and transfer through an ECO. The ECO is a really cool thing that lets you control what changes you're making back and forth between those domains. But I still have to, if I want to explore this design or get net color highlighting to go into the PCB, I have to compile this first. So I'll go ahead and compile it. In 19, we made performance improvements to the compiler. We did that in 18 as well. So it's a lot faster than it used to be, even for quite a busy design like this one. It's already done. And now I can browse through the entire hierarchy in the Navigator panel.
So now, Christian, we've made some changes.
Yes.
And so what's it look like now?
Well, in fact, when Ben did press this button compile, several things happened. It's not only the ERC, it's building up the data model, it's net connectivity, it's hierarchy. All those things happen. And this gets changed in Altium Designer 20. We will have a dynamic data model in the schematic world. So when I go and place one component, nothing should happen usually in the navigator. With Altium Designer 20, we'll get automatically an update here. So this is dynamically. And not only for this navigator, but for all those other worlds as well. So when we have view to the hierarchy, and when we place a new device sheet, for example, we get this hierarchy updated automatically as well.
So no more compile.
No more compile, but unfortunately, the compile button still is available. What does it do? It will be renamed, and it will be the ERC only. So right now, Altium Designer, first time, we'll have an ERC button. Before we had only a compile button, doing the same thing.
So excellent. Now this next phase of things we want to talk about, for my money, are really the star of the show. When we survey you guys, interactive routing is absolutely, positively where you guys asked us to make some investments. Now we, as the world #1 solution, had fantastic interactive routing before. And this is something we've been working on now for 3 releases, which we'll come back to. But I believe that these new capabilities really sort of put some distance between us and the competition now. Now, in the existing experience, Ben, are there any boards that are sort of out of reach for Altium Designer?
No. I mean, really, practically, you can design anything, and it's been this way for a long time. I mean, even several years ago, we had a group at Siemens doing satellite backplanes, ground station backplanes, rigid flex, many, many layers, huge, physically huge.
No, I remember
boards.
that guy. These things were big as a human.
That's right. And so, I've seen a lot of customer designs in the real world that are very, very complex. Some of those folks, had to fight a little bit to get those finished with, compile times and this sort of thing. And so we've done a lot of work to do optimization, but certainly all the routing capabilities are there to get it done.
So when we talk about densities, obviously we talked about densities are increasing quite significantly, and obviously Ben's got this pretty significant BGA package up here. Now, if you could just walk us through the current sort of escape routing on this very dense, crowded area here, Ben.
Yep. So how it works for me today to get out of here, and even this in 19 was a great improvement over 18, was a great improvement over 17. I can get out here. I might have to click in a few different locations. It's obeying my clearance rules. Now I want to go back down here. So it takes me a little bit of work to get out there, but I can get it done, and it's all restricted to 90 and 45.
45 and 90. I like the word you used for it, in San Diego when we did this presentation, Ben. You called it fiddly.
It's fiddly.
It's fiddly, and I liked that word. It struck me as being very Australian as well. So we've gone to the lab on this, and we've created really an excellent experience. And Christian, if you could talk to us about now any angle routing in Altium Designer 20.
So, first of all, we still could do this automatic fan out, of course, which could help us, but from time to time we want to do it manually. And we got some new options. So when I press the tab key, one of the most important keys in Altium Designer to get all options, yeah, I get some new options here. Hugging style, 45-degree, mixed, rounded. Okay, there must be something new inside. So when I start with this one, obviously some people have seen it already, so I'll zoom in a second perhaps. That's a view how I can get out of this.
That's beautiful.
So when we have view inside, this is really well, somehow odd, but intended odd routing, including arcs automatically, including all the things that have been defined in design rules regarding clearances. And here as well, we are able to go in any angle. Any angle we have been able to do before, but show us how to modify something like this, Ben.
Yeah, see, I asked Charles File one time. Many of you have heard of Charles. He was a routing expert. Used to work for Mentor Graphics and defected to the bright side.
To the bright side, right.
Super tremendous, nice guy. But I said to him, Charles, why don't we do any angle routing? He says, because you can't edit it afterwards. That was the answer, and I thought, well, I never thought about that, and I feel stupid for asking you now because, of course. So I have these any angle routes here, and in 19, it kind of does an okay job, but it's still maintaining relative 45s and 90s, so it gets fiddly, and I could get myself into trouble pretty quick if I'm not careful. Normally, I would just delete something like that and start again or use the gloss.
Well, so now you're kind of edging into this sliding sort of zone, correct?
Yeah.
So these next couple of things are really, for my money, the things that people will appreciate the most, that live and breathe routing inside of Altium Designer. And so, Christian, I know you're quite excited about these capabilities. Talk to us about sliding and show us sliding in Altium Designer 20.
I'd like Ben to show an additional thing. Move this one track, this diagonal track. Try to get it down.
This one?
Yes, this one. Okay, thank you. I want to see this. Now we do the same thing in Altium Designer 20. Ooh, much, much better. We do have in the pushing area some additional options as well, all those rounding things like that, and only to show up a little bit what it's capable of doing. So when we start with things like this is an option that we can choose. Should it be rounded, should it be free angle, should it be 45-degree, can be adjusted. So for all those guys sticking to the old world, you of course still can use the engine in the old way. For all the guys enjoying the new things, you can do new things as well. And this works not only for single traces, you can go for differential pairs as well. So when we go for that guy and try to move it a little bit, oh, I get it rounded automatically.
So this is a funny story here because I remember when we were first looking at these capabilities, preparing for this, one of the big things we're like, oh, look, it maintains coupling. And now after listening to Rick yesterday, I don't think that's any big deal anymore, Christian.
So what I want to show you, here again, you can stay with your 45-degree if you want to. It's all a thing of options. Unfortunately, so many options in Altium Designer, but this is what you want. This is your feedback. I need to do this, I want to do that, and we are hearing to you.
You still do want to maintain coupling, and the reason is it's the easiest way to make sure they're the same length.
See, we were paying attention, Rick. All right, so this next capability we want to talk about also, I think, delves into topics Rick is quite familiar with and famous for, and specifically when we talk about length tuning. So we've had length tuning for obviously some time in Altium Designer. But why don't you talk us through some of the current experience, Ben, and see where we're at today.
Sure. So the current state of the art in 19 has a pretty decent length tuning tool. Well, let me start in a different location. Again, you can see maybe I need to. Let me show you on a top layer. I think I was more set up to do this one. And of course, it's got the length gauge, so it'll stop tuning when it's ready. I've got some shortcut keys to adjust, or I can hit tab and move over to the properties panel and make some changes. So I want to do mitered arcs instead of lines. I can reduce the max amplitude. Let's make that 4 millimeters, right? And I can go around corners, and again, there's the option to edit the shape of this length tuning tape, we call it. But the engine's a little slow. You can see there's a little bit of delay there, so it requires a little patience. It works great.
It's fiddly.
It was a little fiddly compared to what you're about to see.
So this is the one that brought down the house in San Diego, Christian, so no pressure. I hope you do it proud. So what are we looking at in Altium Designer 20?
Well, we still can add length tuning. We still do have some option to modify things, but
whoa,
we can move things as well if we want to, see if there's a better location to do it, or if we want to, we even can go and extend
that's
the whole
so
thing.
fast.
Yeah. That's a lot harder to do than it looks, because I asked. That was not trivial, actually, but it obviously is very, very silky smooth. Are there any other areas here you want to show, Christian, with regard to length tuning?
Perhaps some rules
Yeah,
influencing
why don't
it?
we jump in the rules, actually? It sounds good.
Good.
Yeah.
So, some new rules. We got these layer stack things. We have this
Oh,
new
yes,
engine.
yes, yes. Now you've, yeah, I went off script on you, Christian. Sorry about that. So this next thing we want to talk about, I'm going to try the joke that did not land in San Diego, but it's the one I got, so I'm going to try it anyway. So this next capability, Sarah's nodding her head. This next capability, for me, it's about time. And that's tuned for delay. Not one laugh. So what we've done a poor job of in the past, in my opinion, is we haven't put any context around our releases, right? We've been very sort of product marketing in that regard and saying, here's a bunch of new features, check them out. And we didn't put any context in there for you as to what it meant and where it was going. And so what we look at Altium Designer 20, this really is a culmination of a 3-release trilogy done consciously. And the first step was obviously 64-bit with Altium Designer 18. And then in Altium Designer 19, the thing you guys liked the most, at least got the sort of oohs and ahs, was around the layer stack manager. But we really didn't go very sort of frontal when we talk about the field solving technology that we embedded in our layer stack manager in 19. And that was per a relationship that we engaged in with a company called Symbian. So maybe if we revisit, Ben, the layer stack manager from 19, and that'll tee us up for this tune for delay that we now have in 20.
So, and the good news is we have an ongoing relationship with Symbian. So we're going to see more come to fruition over time.
Yeah.
But in 19, if you've used what was new for 19, the impedance profiles, so you can create single-ended and differential impedance profiles. You can choose which adjacent layer is the one that is used as your reference plane for accurately calculating impedance. And you can do width from impedance or impedance from width, and it tells you what your percentage accuracy is there. But a subtle bit of extra information that was added, which we couldn't leverage yet in 19.1, is this additional information down here. we can see the propagation delay, and in this case I'm set up in metric, so it's in nanoseconds per meter. So we've got our propagation delay, we've got our inductance per unit length, nanohenries per meter, and capacitance per unit length, picofarads per meter. And of course, if I switch into imperial units, I'll see it in picofarads per inch, for example. And that's super useful, but to create length tuning rules in 19, I still have to come in here, read the propagation delay, write it down on a piece of paper, go back into design rules, and set up the actual length tolerances that I want as actual length based on what I measure here.
Well, in which we all now know after attending Rick's talk that tuning for length.
I'd much rather just type in
right.
the window from the eye. This is how much I've got on either side of my clock sample.
And so, what we put into 19 was great and people loved it, but it lacked really practical application. What we should have done in retrospect was let you know where we were going with this. And where we were going with this is absolutely what Christian's going to show us now with tune for delay.
The problem with this propagation delay, it's different where you're located on your PCB. If you're on the outer layers, it's a different speed. So 550 at the moment, something like this, and this is 630, something like this. So it's different if you're on the outer side of the PCB or on the inner side of the PCB. And our length tuning, or the rules, they have been quite fine so far. But as we learned yesterday, it's not the length, it's the time we have to tune. It's all about AltiumLive. It's all about AltiumLive. So when we go for lengths, we can go for the units still, but we can go for the delay as well right now. This is only the length or only the time that we go for. I think more interesting is a match.
Wait. Does that mean we can now have a 0 picosecond trace?
We could, yes.
So you can put superconductors in the layer stack manager.
We'll get many errors. So we do have the delay units here as well, so we can go for a time, not for a length, which is, well, it's somehow not the real thing.
Right, sure. Well, Christian, now while we're in here, I know that you specifically requested that we talk about return path. And I know you really wanted to talk about that, and that actually came up. I spoke to Rick about it privately, I think, and he was very excited about the ability to have return path.
I don't like to talk about return path.
Well, okay.
I'd like to talk, it's all about the space.
Thank you.
It's all about the space, and I'm not singing it. Who has been with us last time, AltiumLive, doesn't matter if it has been in Americas or in Europe. We have learned that if we go impedance controlled, we have to control as well that our reference layer is underneath the signal, that we don't cross reference layers, that we don't change potentials, things like this. And we got a rule to control this. And this is, in my eyes, fantastic, because we taught everybody in AltiumLive, go for impedance control for every signal that literally has a change in it, a digital change. Go with 50 ohms as a rule of thumb, then it will be fine, and we'll have no problems with signal integrity, things like this. We can control the thing. Having a distance to the border, controlling if you're skipping something, and we even can exclude, of course, the wire holes, which is a must. Yeah, we do have some things here, usually, but this can be controlled right now. And I'm 100% proud that we get something like this in Altium Designer. I thought this would be far in future, and we got it right now.
And it works great. I've played with that, and in a BGA breakout is where you really run into those things without realizing it.
Yeah.
This will catch the error every time.
And it's not only one or two signals. It's many, many signals on our designs these days.
So Christian, since we're in the rules, and I know this is also something that you requested that we specifically show, you felt it had sweeping impact. I had a different opinion. Mm-hmm. But strangely, the first person I talked to about this capability, I just sort of mentioned it in passing. And he said, well, no, absolutely, that's exactly the type of design work that I do. And these are the new creepage rules. And I know you wanted to talk about this.
Creepage will be part of Altium Designer 20 as well. So right now we can go for these gaps in the PCB having an impact on the clearance of signals. I had quite some people asking me for this, quite some prospects or potential new customers. They've been asking for this. Most of them, even if we did not have it, bought Altium Designer, most of them at least, and right now we do have this. And on roadshows, I had exactly the same thing. And what did I do? I've cheated Altium.
You cheated?
I cheated Altium. I asked all of them to go for the idea section and to make them me too.
Oh, I gotcha. You started a
And
movement.
right now we do have this wonderful, or we did have this wonderful discussion in the forums in combination with our developers. Most of the guys are not aware that they really take care about it because it's not really moderated.
Yeah.
But our developers do have a view to it and do discuss on these forums.
So we'll talk about that in just a second. But for now, I'd like to, if you guys could give the boys a round of applause, and we'll ask them to exit just quickly. Now, thank you. I'm sure most of you already know this, but you can go to our, what we call Altium Alley there, and we have demo stations, and you can interact with all these new software that we're bringing to market space. So go and have a look, give it a go. But that should be available in November this year, Altium Designer 20. Now, that's not all we did. We added some additional capabilities. Here's just a simple block diagram I put together that shows the sort of functional editor, if you will, or area of the product where we've made some enhancements. For my money, that interactive routing, I think, is where you guys are going to really feel it the most. It's really silky smooth, as you saw. And we actually, in beta and alpha, we had almost 3 times the number of people interfacing with it. And so this is something that really also, when we talk about user centricity, making a conscious effort in investing in, which is really, really, really vetting our alpha and then our betas with more and more people. So if anybody wants to participate in our beta group, and there's many of you here, by all means, just go to the community section on our website, fill out the form, and we're pretty non-discriminatory in that regard. So please do that. Now, some other areas I'll highlight. We did add a new SPICE engine. So this is an area much like schematic where we really hadn't done really much development whatsoever in many, many years. And it was a bit aged, in my opinion. So the first thing you'll notice is with this new engine that you should have no more problems with models. We were sort of, dare I say, sort of 3 out of 10 models that would work. And now you should be closer to 9 or 10 out of 10 models should work. The experience today is the same as it was, but coupled with that DirectX capability that we added in the schematic side, you will see future development that will make a significant enhancement. I think there's a bit of foreshadowing here when you also look at that field solver technology that we have put in the product. I think you can kind of clearly see where this is going when we talk about analysis. And I know, I hate to pick on you, Rick, but you're sitting right here. You know, I know you're a big advocate of those field solver technologies, clearly, but true to Altium format, it will be part of the suite, and minimal financial impact, if any. So that's just kind of how we operate. We like to democratize these very high-end technologies. We talked about the cribbage, some multi-board enhancements. When we talk about ActiveBomb, supporting the entire project now, as well as the 3D PDF being fully supported, and also some new library migration stuff, which will make sense when we bring up the next gentleman. So when we talk about this next topic, I think this is an area where we try to be quite transparent. I know that some organizations don't even say the word bug. We absolutely do say the word bug because, quite frankly, that's what it is. Software has it, we are software, and why should we try to pretend that it doesn't exist? And when we look at what you guys value in your subscription dollars, although we're going to make some significant enhancements in the coming months to your subscription product and adding some significant value there when we talk about Altium 365, today, for the most part, 67% of you guys tell us number one answer, bug fixes, okay? We've, with this release, really made a conscious effort. As I said, we increased the beta group, increased the alpha group, but we also, in a very meaningful way, made a point of being far more engaged. And when I talk about this user centricity, this is an area where you absolutely see a significant difference in the coming weeks. We've made organizational changes to where you will feel this. And if you go to our forums, we are making significant investments in making that a meaningful watering hole where you can engage directly with the people that develop this product, okay? And there's service level agreements that we have internally, that we're holding our people accountable to making that meaningful for all of you guys. Now, we absolutely do listen to all of you when we talk about which bugs we prioritize. And in Altium Designer 20, we've sort of redoubled our efforts here. Now, what you see along the top is the squiggly line. That's the number of people that voted that were impacted by the bug fixing that we undertook in Altium Designer 20. So you can see a significant improvement in the number of people we're able to affect in a positive way, and just the pure number of votes that we got. So we started marketing Bug Crunch for the first time ever, really, with 19.1, and we've seen an increase in engagement there, and I would encourage all of you to go there. If you have a bad experience, my information is public. It's lawrence.romine@altium.com. You can contact me directly, and I absolutely make sure you get taken care of. But you can also see we've addressed, it'll be about twice the number of bugs as a whole than we did in the previous release, and we've been making a very linear climb in this regard. So with that, I'd like to introduce a gentleman that was actually here last year. He has recently been named our Chief Software Architect. His name is Lee Gahn, and he's a great guy. Come on up, Lee.
Morning, AltiumLive. Good to be back again this year.
So we've got an audacious portion of the keynote here. In San Diego, we called it ambitious. But
very ambitious.
This is why I like to work at Altium, because we do things like AltiumLive that nobody else will do. Now, Lee, you were here 12 months ago. Well, actually, it was a little less than that because we did it in January last year. On this,
well, 10 months ago.
We were in Munich 10 months ago, and you talked to us about the thing you've been working on, and that would be Altium 365. But what have you been up to the past 12 months?
Been busy. Been really busy. So last 12 months.
10 months.
Huh?
10 months.
10 months, yeah. Okay, so last year we've been working really hard behind the scenes to continue to evolve what is the Altium 365 platform, to gain maturity on it and to really make sure it's ready for prime time. I think you can appreciate, building such a system, there's many challenges behind ensuring it has high availability, that it's scalable, that it's robust, that it's secure. So we've just been really extremely focused on ensuring that we keep things simple, convenient, as we talked about last year, and that they just work out of the box. The user experience, really, from that first engagement through to everyday use has also been constantly under the spotlight. And that's an area that we've been really putting a lot of effort in to make sure that it's really user-friendly and it just works for people. So the last year, 10 months, has been really busy, and it's flown by in that respect.
Well, Lee, actually, it might be beneficial if you just explained what 365 is. What is Altium 365?
Sure. So, in its simplest words, Altium 365 is our cloud platform, okay? Its purpose is to make things easy for you by simplifying collaboration between all of the stakeholders in the value chain of electronics design and realization. The long-term vision of this platform is to connect design, manufacture, and supply chain in a way that really transforms the experience of designing and building electronics. Okay? Now, being a platform, applications are designed to run on top of Altium 365, and our first application that we have running on it is called Concord Pro.
So, then what exactly is Concord Pro, Lee?
It's another good question. Okay, so Concord Pro is our design data management application, okay? And it has a specific focus on component library management and the ECAD, MCAD interchange. Concord Pro can be run on the Altium 365 platform, as I just explained. It just works out of the box, which is a really important thing. Or you can purchase it, run it on your own infrastructure, should you wish to do that on-prem.
So what's the current status of Concord Pro running on Altium 365?
Okay, it's a good question. Our closed beta program, which we've been running over the last kind of 12, 15 months, has now come to an end. So I'm really pleased to say that Altium 365 now has general availability. We're open for business. So today, what I'd like to do is to share with you the experience of one of those beta customers. We've got a beta customer who's been on the platform from a very early age, for about the last 15 months. It's called Skyships Automotive. they've adopted Altium 365 in their production environment. So what we're going to show you today is exactly how it's working for them to give you a real understanding of how it's supporting their business.
Well, let's watch the video.
Let's do it.
A supercar is something that's been on your wall in your childhood dreams. So when you get it, it's your pride and joy. It has to be perfect. You will cherish it and you'll polish it and you'll look after it, and that makes them special. Our products have to supersede all expectations and be better than anything else that they could buy. We are a tier 1 automotive manufacturer, so we supply the automotive industry with electronics, specializing in infotainment systems and digital clusters, and we are responsible for everything from the design, the manufacture of the hardware, all the software and the graphics, to what the user experiences when you buy your car. Infotainment systems, pretty much everything that you would find in a screen today, connecting your Apple CarPlay, connecting your phones, Android Auto, your Bluetooth, making calls, the comfort features of the car when it's too hot, and these days the display that tells you how fast you're going or if there's a safety warning, and that encompasses what people describe as infotainment.
What gets me excited about the design process is the ability to see my designs in the real world, seeing them going down the road in cars. We spend a lot of time collaborating with different groups of engineers, customers, mechanical engineers, software engineers, and all of them want to see what we're doing in the way of schematics and PCB layout. So this is where Altium 365 comes in very handy. We use the Altium 365 workspaces as a way to keep all our components and designs and projects all in one place so that everybody's working from the same source of information. It's also useful for keeping track of those parts as well, and we find the version control system in that very useful. We can look around the board, identify components, test points, nets, all the things that we need to find when you're out in the lab probing around and testing. Altium 365 has allowed us to transfer the information to manufacturing in a clearer way so they can see precisely where all the components are supposed to be and the orientation for them.
When we receive the design from engineering, having Altium 365, it allows our production team to actually go on the web using Altium 365, and we can review the data up front before we commit to doing a design. The ability to add comments has tightened up that feedback loop between production and design. So when we are doing a first off, we can check component heights in 3D before we commit any board to going through a reflow oven. It's great because we can also check beforehand as well as when the board is actually being built. So if we suspect there's going to be any component clashes, we can adjust for that in our process. If you're at a party, you're always introduced as, oh, this is the guy that works on this car. And they all go, oh wow. It's a little bit overwhelming sometimes, but it's a nice feeling.
I've always designed things, I've always made things work. Right from early days in school, I was the one that was making things when everybody else was doing proper work.
We found that production and design are working better together. We are now able to design faster using different teams at our different locations. We had invested heavily as a company in our production equipment and software, and our ECAD design department was lagging behind and had become disconnected. The cloud systems and increased collaboration offered by Altium was the way forward for us, and has helped us increase our productivity and the link between design and production, and that's why we chose Altium.
Thank you. Okay, so today we've got a little bit of a show for you. All right, we're going to demo the power and capabilities of Altium 365 and Concord Pro as they exist today. Okay, so everything you're going to see right now, you're going to be able to do. It's all running on the production environment. All right. Now, for the purposes of this demo, we have one really ambitious customer. Okay, he loves to push the limits, and he's asked us if we could complete an entire design for him from scratch, including an enclosure, in 45 minutes. All right? Now, this is slightly crazy, but with the support of my wingman here and design guru, Mr. Ben Jordan, and various other collaborators that we're going to have come in and connect with us today, leveraging the power of 365 and Concord Pro, we might just be able to do this. All right? So everything you're about to see here is going to be done live. Nothing's pre-recorded, and there's absolutely no safety net beneath the tightrope. Now, unlike a dangerous magic trick, I do encourage you, please do try this at home and the office and anywhere else that may be convenient. Okay, so let's get started. Very first thing. Okay, what you're seeing here is altium.com/Concord. You can come here and basically sign up for a free trial, and this is how you can get started with Concord Pro. Just click on the box in the top right. It's going to ask you a couple of questions. Ask your name. Ben's already signed in here. You can sign up for your AltiumLive account. Choose your location. So this is a location that's geographically closest to you, where your Concord Pro workspace is essentially going to be hosted. Okay, that's an important one. You want that to be closest to your team, so you're going to get the best performance out of it. But it will work globally. You can be anywhere in the world and connect to that workspace. Once you've clicked that, you're going to get an email basically telling you that we've received that request, the workspace is going to be provisioned, and then you'll get a follow-up email from this when it's actually been done. It'll only take a few minutes. You can click on a link inside there, and it's going to take you to the Concord Pro workspace. Another way that you can access this is through the dashboard, which is the way that Ben's going to go there now. So we're going to come into the dashboard, we're going to click on the Workspaces button, and this is going to take us into the workspace. Just click on Sign In again here. So if you do sign out, yeah, there we go. Okay, so we're into the workspace. So when you're in the workspace, you're going to be taken to this homepage, and there's a bunch of videos on the homepage which are designed to really kind of lead you through Concord Pro, make you understand how you can use it, show you some common use cases, this kind of thing. There's also step-by-step guides with kind of pictures, step-by-step instructions of how to do certain operations, certain things. That's all on the homepage inside Concord Pro. Okay, so very useful for just helping you get up to speed with things. Now, if we go back into that workspace again.
That was me.
That was Ben. User operator error here. Okay.
I'm lucky I've got multiple workspaces.
That's it. So that's it. Normally you'd only have one workspace. You can click on that and go directly into it. But when you've got multiple workspaces, you can kind of come in and out them as you please. So what we're going to do now, I just mentioned that we've got a bunch of collaborators that we're going to actually bring in and collaborate with us today. So Ben's gone into the users menu, and we're actually going to add some users to our workspace, essentially bringing people into the team. So as we type their names, we're going to get a prompt for their email if they're inside our organization, as these three guys are. They're all part of Altium. But you can put in email addresses for anyone who's outside of your organization as well. So there's no restriction as to who you can invite here. If you invite someone from outside your organization, it will actually prompt you and tell you that. So from a security perspective, just to make sure that you know who you're inviting. Now, from a roles perspective, we're going to make these guys all administrators because we trust them implicitly today. You can have other roles here, so you can define things like librarian, mechanical engineer, PCB layout engineer, and that allows you to have a fine-grained kind of access control and control who can access what inside the workspace and from the project perspective. Okay, so just click the invite. What's actually happening now is a bunch of invitations will be sent out to these users. They'll get them in the email box, so they'll be able to get that email, click on it, and again, come directly into the workspace. So now we've got our team set up. We are pretty much ready to go. So we're going to switch back to Altium Designer. Now, 365 and Concord Pro, they're kind of woven into the fabric of Altium Designer today. So it's actually very, very easy to connect to that workspace. All you need to do is use the top right-hand corner, drop down, and you'll see we've got our workspace there, AltiumLive Demo 2019 DE. You can see that Ben's got a bunch of other workspaces there. So if you've got multiple workspaces that you can access, they will also all appear in that drop-down. Okay, so we've got that workspace. We're now connected to it. What we're going to do is go ahead and create the project within which we're going to do all of our work today. And it's the same process that you would normally use inside Altium Designer. File, new project. In this case, we've got the location set as AltiumLive Demo Workspace in the top left. So this tells us that we want to create a project within the context of Altium 365 and Concord Pro. And what we've also done is we're using project templates today. So this USB stick, which is the product that we're actually going to create, it has a component, it has a template for the schematic. So we've got our own kind of custom schematic size. We've got the logo in the bottom right-hand corner. We've also got a PCB template there, which we'll see in a moment, is actually has a predefined board outline and a couple of components already on it. One of the other things that we're also using for this particular demo is what we call formal version control. So Altium 365 has built into it an underlying Git version control provider. And we're going to use that. Now, you don't have to use that. You could uncheck a checkbox there. If you've got your own external, say, version control system, be that Git or SVN, this system also works with that. So the important takeaway there is that this isn't an all or nothing. You can pick and choose what you want to use in terms of the individual component parts of the system. So we've got our project created now. You can see this appears in the Explorer as normal in the top left. And we've got some blue check marks, which essentially tell us that the project's been created. It's on the local hard disk of the machine, but it's not actually been pushed up, committed to version control and pushed up to the server yet. So that's what we're going to do right now. Just right-click on it, send to server. I'm going to put in an initial kind of comment here just to say what it is. You know, this is the first commit of this particular project. And then we're going to commit and push this up. And that'll just take a few moments to go away and do that. Now, once we've done that, this project is now residing in such a way that any of our collaborators can come in and kind of access that. Well, they will be able to actually after we do the next step. So we've gone back to the web browser interface, and I just want to show you the way that you can access your projects in this case. So we're going to go to the Projects tab. And here you'll see this is our USB auth key project that Ben's just created. So it appears straight away on the web. We've also got this nice 3D rendering of the board, which is automatically generated. And down the bottom, we've got previews of it, so you can easily identify the project. Okay, you can see that there. Now, we're going to click on that ellipsis, hit the share button, and this is where we can configure. You can also do this inside AD, but I just want to show you this on the website of things today. This is where we're going to actually configure who can access this project. So you could individually put, people's emails in, or you could have a specific role or group you wanted to share to. But in this case today, we're actually just going to open this project up to everyone who's currently in our team. So we're going to put a little note in, hit can write down the bottom, and share this. And we're pretty much ready to go. So 2 steps we've done. As you've seen in the last few minutes, we've come in, we've set up our team, we've created a new project, we've shared that project, and we're ready to continue on and crack on with this design. Okay, so at this particular point, what we're going to do is Ben's going to start the schematic capture part of this process. All right, he's got a schematic in mind. He knows what parts he wants to use, but we've actually got a couple of parts that are missing, all right, that we want to have brought in. And what we're going to do is we're going to invite our first collaborator, who is Casey, and he's going to come in and being connected to this workspace, he's actually going to create a couple of parts for Ben using 2 different approaches, one with the manufacturer search panel and one using this single component editor. So you get an understanding of how component management actually works inside Concord Pro. So if we could Q4, please, and switch to Casey. Hello, Casey. I'm going to hand this over to you for the component creation side of things.
Howdy, Lee. How you doing over there?
Very well, thank you.
Fantastic. I'm kind of starting to regret telling Ben that I'd be available whenever he needed me for part creation, but on the plus side, at least, the stars at night are big and bright, deep in the heart of Texas.
Excellent.
Let me go ahead and show you my screen so that I can take you through the part creation process in Concord Pro. Okay. So we should be looking at my 80/20 design environment here. The first part that I'm going to create today, luckily Ben was kind enough to get in touch with me ahead of time and let me know a couple of the parts that we're going to need. And the first is going to be a generic resistor that's found in a pretty commonly available package. So the first thing that I'm going to do is I'm going to pull up the manufacturer part search because as we know that there's a lot of components that the design team at Altium has already created the schematic sheet symbol and PCB footprints for. And so if this is the case, it's always good to go ahead and check to see if they've already created the part that I need. In this case, I know I need a chip resistor. And when I select this filter here, this goes off and searches through our SIVA Octopart network and pulls all the different available parts. And you can see we have over 280K, or I'm sorry, 820K, pardon me, my dyslexia got me there for a second, but 820K different results here. So I'm going to go ahead and narrow this down a little bit. And if you've ever used our file-based library search, one thing you'll notice is that our search capabilities here are greatly improved. So I'm going to narrow this down. We want a 220 ohm, 0402 package, and for example, a 5% tolerance. When I hit enter, it really, really quickly now narrows that down to only 329 available components. From this window here, we can see all of our parametric information for the selected component up here, as well as our available schematic sheet symbol and 2D and 3D footprints for PCB. I'm going to actually explode this window out a little bit more so you can see what's going on a little bit better. But we notice that because we have 329 components, I still want to maybe filter this down a little bit more. So you notice we have this filter capability here on the left, just like any of our major supplier websites. I'm going to come down and further refine my search. For this case, I'm going to first say, is it in stock? We want to make sure that the part's widely available. I'm also going to specify I want it to be RAWS compliant due to the design requirements for this project. And we're lastly going to specify has model. I'm going to narrow the search down only to components that have that green IC symbol, that have the predefined schematic sheet symbol and PCB footprint. So now we've narrowed it down to 100 results. This is a lot more manageable. If I find two components that are very similar, I can do a control click here. For example, this Panasonic versus this Yagio. If I control click and highlight multiple parts, one cool thing is that I can do a side-by-side part comparison here in my manufacturer part search. All of my similarities are in white, and all of my differences are in red, and that even goes through our different models down here. Since there's no huge difference between the two, I'll just select this Panasonic for example. And also I do want to mention that we do have that supplier information straight here in the manufacturer part search as well. So all these guys are hyperlinks. If I click on this, for example, it would take me straight to the DigiKey website, to the supplier page for this part number. So that's really, really handy. I'm going to go ahead and bring this into my library. Now you may be familiar with the traditional process, which is to download. But what I'm going to do is acquire, and this will bring it straight into my Concord Pro library. First, I need to define which folder it's going to live under, and in this case, it's going to be a resistor. This is an implicit parameter type of every component created in Concord Pro. When I say OK, it's going to bring in all of that data from online, from, like I mentioned, that SIVA Octopart network. We have access to 160 different suppliers worldwide, so doing our part search this way is literally the equivalent of going online to SIVA Octopart and doing your part search that way as well. So I selected that we're going to choose all data, including all of our parametric data and our sheet symbol and PCB footprint. And when I close out of that, you notice that all that information has already been brought over. A couple of things that we want to do here, though, is for example, you see here in the parameters, many of these were brought over automatically. Part of this is defined by the template for the resistor category, but a lot of these is extra information that's brought over from the manufacturer part search, including in this case a link to the data sheet. So that's very handy. One thing I do need to put in, though, is we notice this value field here is input empty. This is part of the template, so I do need to go in here and put 220 to represent my ohms there. Notice that that part choice came in down here in the part choices, and our description and name is all brought in, and in our advanced settings, we can see the folder structure. Now, one change I do want to make to this before I release it is this schematic sheet symbol. You can go ahead and edit this component. And this is all in a fileless editor. You'll notice that all of this is happening within the Altium design environment. We're just creating new tabs here at the top. And in this case, I want to be able to see the value of my component straight away from when I place it. So I'll go ahead and say save, and then close out of this one. And now you see that updated tooltip there for this schematic sheet symbol. So this guy's ready to go, save, and then I'm going to click this button to release to server. So that's how straightforward it is to create a new component from the manufacturer part search. It took about a grand total of 3 minutes to bring in that part, all that data. And of course, always document your changes. This is our initial release. Say OK. And generally, our message window pops up here. No messages is a good indication that everything is succeeded correctly. So we'll wait for this guy to go ahead and push. There we go. having to think a little bit since it's having to go across the Atlantic, I think. Okay, so that was number one. Number two, we're going to create a new component from scratch. This next one's going to be a memory IC. And I happen to know that we're not going to be able to find that on our manufacturer part search. So I'm going to come to File, New, Component. And once again, we're going to choose that category. In this case, as I mentioned, it's a memory IC. So we're going to go to our Integrated Circuits folder to our memory. Say OK. Now this will open up, you notice, a different template. As we kind of mentioned before, each different folder category has a different template assigned. Now, since we won't be able to print in the schematic sheet symbol or footprint, but we will be able to use one of the features of that SIBA octopart network once again. Ben was very specific about the part he needs. This is going to be an ATAES 1324. Notice that this is automatically filling out as I type in up here, so the tool is smart. Go through and identify that part number based on.
Casey, I need
I think we're missing the.
It's a 132A.
Oh my goodness gracious! So
my handwriting is so bad. My A's look like a 4.
I'm so sorry. I think that's what you wrote. I just am being a little cross-eyed right now. I apologize. Thank you for the clarification.
At what time is it there?
That's 3:15 in the morning, actually.
I appreciate your help a lot.
You'll have to thank Matt even more when we switch over to him. I think we get some beers next time here in the States.
I owe you one.
All right, so as you can see, it brought in all that information straight from the manufacturer part source. Once again, all this parametric information is filled out. Now I just need to go through and add my symbols and footprints. So I'm going to go through to my wizard here and start by creating my schematic sheet symbol. Now we notice that because over here we actually define the number of pins in our parent parameters. Let me close this for a moment just so I can show you here that the number of pins here is 8. So when we enter this wizard, the tool is smart and automatically predefines 8 different pins now for us to go for. I can choose whether I want dual inline, quad, single inline, any way that I want to configure. But also Ben has provided me with the pinout and the position that he wants. So I'm just going to go ahead and copy from this spreadsheet and paste here. So you see quickly that was able to be transferred over, and we'll say OK. And now we are back into our schematic sheet symbol editors. The last thing that I need to do is assign a default designator. In my case, I like to use U. And then we'll just say OK. Save here. Okay, so that's that part. Now I'm going to add the footprint from our wizard as well. I'm going to come in and select. You can see that any of the IPC different compliant footprints are supported here. So we have things like our chip array, our tool inline package, all the different types are supported. In this case, I'm going to stick with the SOIC. And next. And then here we can go through, and from the data sheet, I can read off all the different package dimensions. This one happens to already be aligned with what I needed here, but one thing I want to make sure that I do is click this Generate Step Model Preview down here. This will give us that detailed, nice 3D body for whatever we do our component placement on the PCB. Go through and select Next so that we can go through the rest of this wizard, but we have options, for example, if you need to add a thermal pad, you can choose your density for low, medium, or high density for IPC compliant footprints, and we'll just go through and click Finish here. So this opens up our PCB footprint editor. Here's a really nice footprint that the wizard created for us. And according to my company regulations here, first I'm going to select this pin 1 here, and instead of rounded, I'm going to make him rectangular. And then I'm going to delete the silk screen here on pin 1. That's looking pretty good according to what my company requires. I'll go ahead and save him and close. And then now when I come into here, I don't know what happened to that one. Let me trash this guy and try that editor one more time. I apologize. That was sort of a little goof on that end.
I think it was the deletion of the name that probably did that. But not to worry, it's 3:15 in the morning, so.
I do apologize, guys.
The point is, it is so ridiculously fast to make components.
Indeed.
That, you know, it's barely a hiccup. It's great. Looks perfect, Casey. Thank you.
That's great. So that's as quick and as simple as it can be to create a new component for So I'll go ahead and kick the screen back over to you guys so you can continue on with the design.
Thank you very much, Casey. So we've just shown there two component creation kind of separate processes. One is acquiring from manufacturer part search. The other is using single component editor with these wizards to build them out. We've seen how quickly that is. So both of those parts have now been released. Ben will have access to them. And he's going to show you basically how he can just pull those parts into the schematic and continue to wrap up the logical part of the design capture process.
So this is the resistor Casey just added using acquisition. It's the Panasonic part, and he's done a great job. And using one of my favorite schematic features where you get to just insert parts into an existing wire. I've put all my dropping resistors in for the LED. Now, the one last thing is the actual SPI encryption device. So that's the ATAES132A. And there it is. And of course, if I drag that up, I'd see the full preview and be able to check everything out. Looks fantastic. And he's even put all the pins exactly where I wanted them. So the last thing to do here is wire up power and ground to this device. Throw some no ERCs. Don't need to do that, but I'm kind of a stickler for those things. And I'm ready. I'm ready to push this over to PCB, except I have to annotate everything. So let's do that really quick. Annotate quietly. Yes. Save everything. And I'm going to update the PCB document with the unified models. And I forgot to adjust my project settings, but for this kind of small project, there's no BGAs, so I don't really need to use rooms. So I'll turn that off. And something I really, really love about a proper managed component system. I will never, ever, ever again in my life see the little red cross that says footprint not found. That is now reserved for when you find a broken link on the Altium website.
All right, so let's take a look at that PCB document with all of these parts pushed to it. Ben's just going to quickly move these into the center of the board. And then as soon as that's done, we're going to commit this design back to the server. And as the next part of this, what we're going to do is actually have an MCAD engineer create as an enclosure for this device. Okay, so we're going to show you how the ECAD-MCAD collaboration inside Concord Pro works today. All right, so once this is completed, again, it's the same process, just right-click, save to server, very straightforward. Put a nice comment in so you know exactly where you are in terms of the design phase itself. What we're going to do is switch to the MCAD Co-Designer panel, which is a standard part of Altium Designer, but enabled through the Concord Pro connection. We're going to actually push this design into the MCAD domain. So we've got this concept of ECAD-MCAD domain. Obviously, in the ECAD side, we're doing all the electronic stuff, in the MCAD domain, all the mechanical side of things. So we're going to push this from the ECAD space into the MCAD space. And what does that mean? It means it's going to the Concord Pro workspace, and it will then be available for an MCAD engineer using one of three tools that we support today, SolidWorks, PTC Creo, and Autodesk Inventor. Now, today for this demo, we're going to be using SolidWorks. So I'm going to bring in another collaborator, which is Matt. If we could cue him on 4, please. And Matt is going to show us how we can use this really powerful MCAD-ECAD co-designer capability to do an enclosure and effectively bring that back into the Altium Designer world. So Matt, good morning. I'm going to hand over to you now. If you could talk the guys through how you do this and show them, that would be great.
Okay, Lee, thank you so much. Good morning, Lee. Good morning, Ben. And good morning, everyone there in Frankfurt. I'm coming to you live right now from Boston, Massachusetts, home of none other than the 6-time world champion New England Patriots. Go Pats, baby. All right. So I'm going to start sharing my screen now with you guys as the MCAD user. Right now, about now, you should be seeing my SolidWorks 2019 window.
We got it.
And be taking you through is exactly what Lee said. I'm going to take you through how now, as an MCAD user, I can take that same exact design that we're currently working on in Altium Designer, and through the Concord Pro workspace that I'm also pointing to in SOLIDWORKS here through this Altium Co-Designer panel, I can actually take what that current status is of that PCB that was created in Altium Designer and actually build a native SOLIDWORKS assembly file out of that and start working with the board file in the context of our actual product in the MCAD assembly. So the first thing that I'm going to do in the Altium Co-Designer panel here is I'm going to click this button right here that says pull board from server. And what that's actually going to do is it's going to bring up the window here for me to select which project I want to now build that MCAD assembly from. So what we can basically see here in this select project window is we can actually see those same groups of projects that we had in our Concord Pro workspace. And I'm going to select our product that we're working with right now, which is of course this USB product. So once I go ahead and I click on the USB product, I'm going to go ahead and click the open button. And what that's going to prompt me to do is just select a location where I want to save the resulting SOLIDWORKS assembly. And I'm just going to go ahead and save it in this folder that I have right here on my desktop. Now, once I click save, what this is going to do is it's going to go again and look into the Concord Pro workspace for that design data that was pushed in on the Altium side. And right now it's actually pulling all of that design data across the Atlantic here to Boston, and it's going to go ahead and build that native SOLIDWORKS assembly. So you can see over here on the left, I have a assembly tree that's being built. I've got the top level assembly right here, given that has the name of our product. I can see that it's also creating a part file for the board, and it's also creating all of the part files in native SOLIDWORKS for all of our components as well. And it's able to actually leverage all of that embedded 3D information that we had in our Altium footprints. So again, look at that. Just in a matter of really 30 seconds or less, I was able to pull that design information all the way across the Atlantic from our European workspace and build it here in the United States in my SOLIDWORKS program. As we would say in Boston, our software programs are wicked smart. Wicked smart. All right, so now what I'm going to do is I'm actually going to go ahead and bring in the enclosure file that we had mentioned, and I'm actually going to now just fully assemble my product here in SOLIDWORKS and actually redefine the board shape entirely within the context of our whole entire product assembly. So to do that, what I'm now going to do is I'm just going to simply go to my insert menu here in my SOLIDWORKS assembly file and add an existing part or assembly. And in the background, I already actually have the assembly file for our enclosure. So I'm going to go ahead and click on that here in the window. I can see that it's being brought in fully rendered as well. I'm simply going to do a rotate 90 degrees about the x-axis, and that's just going to make sure that I actually get it in the right plane with the PCB file that I have here at the bottom of the assembly window. So I'm going to go ahead now and just simply place it in the environment, and I'm going to go ahead and actually just fix this connector as well, and that's just going to allow me to actually define how I want this board to actually go into the enclosure in the context of that connector, because as the mechanical engineer, connectors are one of the really critical PCB components that I want to make sure I have positioned correctly in the assembly. So the next thing I'm going to do is I'm simply going to go ahead and just hide the top part of our enclosure here. And just using a couple very simple standard mating features within SOLIDWORKS, I'm going to go ahead and actually line up the enclosure to the connector just to make sure I get it in the correct place for the alignment of not only the connector but also for the board itself. So I'm going to select the bottom face of the enclosure there, also select the bottom face of my connector, make a simple coincident mate, just having those faces touch each other like so. And then I'm going to do the same thing on the side part of the connector here in the inner side wall of my enclosure. And I'm going to scroll in just to make sure I get the right one. There we are. Coincident mate. Perfect. So now I can see that I have those faces aligned correctly. So now for that, I can go ahead and remove the mates because I no longer need them for the alignment purposes. Yes to all. Very good. Then the next thing I'm going to do is I'm just going to move the enclosure down a little bit because I actually want to bring it in contact with the height face of my board here. And I'm going to go ahead and select this inner wall of the enclosure as well. Do a nice quick coincident mate again. There we go. So now that everything is mated up the way I need to, aligned perfectly, I'm going to go normal to the face on my board. And again, just remove this mate because I've done the alignment based on the mate that I needed. I can simply remove it now. And so what I'm actually going to do at this point is, as you can see very clearly, I can see the bottom outline of the enclosure here, and our current outline for our PCB that was brought in from Altium Designer is really quite outside the limits of the bottom half of that enclosure. So what I've actually done in the background here in the bottom of this enclosure is you can actually see that I've taken a sketch here in the bottom part of the enclosure, and I've actually defined the mechanical constraints of the board and given it the proper clearance of the inner walls of the enclosure. So what I can do this is one of my most favorite features in the SOLIDWORKS program, is I can actually leverage that existing sketch to fully redefine the shape of our board. And again, everything's in context of the whole product, so I get the full view here right away. So I'm going to go ahead and actually just edit the sketch from my board file here, again, fully in context of our product assembly. And when I click Exit Sketch, the only thing I really need to do now is I can take the current entities of the sketch for the board extrusion, I can remove them, and then I can simply just click on the sketch that I've defined in the bottom part of that enclosure file. And I'm going to use one of my favorite features in all of the SOLIDWORKS program, this Convert Entities tool. And this is actually just going to allow me to simply redefine the sketch of our board fully to the sketch that I had in the bottom of the enclosure there. So now I can simply exit out of the sketch. It'll redo the extrusion from my board file, and then when I click out of Exit Component, it's going to bring me back up to the assembly itself. And I can see right there, as soon as I do all of those nice, quick, easy steps, I have been able, as the mechanical engineer, to make sure that my connector is fully in place to where I need it to be, and our board file is fully redefined within the constraints of the enclosure. So once I'm satisfied as the mechanical engineer, all I simply need to do now over here on the right in the Altium Designer Co-Designer panel is simply click the push, and I'm going to give Ben here now a note, just letting him know that I've redone the board. He's all set. Bring back into Altium. And I'm just going to simply click post, and that's going to take my design again from here all the way in Boston, Massachusetts, and push the current state of the design back over to our server in Europe, and now Ben will be able to take it and do what he needs to do from here.
Thank you
Thank
you very much.
I will give it back to you.
Thank you very much, Matt. That's great. Okay, so let's just go back to Ben now. So Matt's pushed that design back into the ECAD domain, and you can see that we now have a notification in the MCAD Co-Designer panel to say that some changes have been made. So Ben's going to pull this back. Now, I'll let Ben explain a little bit more about this panel and how this works and how you can see these changes prior to actually bringing them back in.
Yeah, so this panel is a lot like the schematic to PCB or PCB to schematic ECO. It gives you a list of the proposed changes. So as the master designer of your domain, you get to choose what you accept or reject. And so here I can see Matt's made a few changes, and some of those I can preview. This one here is obviously a new 3D body is coming in. That must be the enclosure, and it's giving me a preview of where that's going to be. I'm currently in 2D mode, and if I look at board outline, it shows me the board shape that's proposed, which is exactly what we need. And of course, this all works in 3D as well, so I can see the proposal. If he'd moved any components, which mechanical designers often will have to do that, he could have moved that push button into its position. In our demo, we're actually going to have the PCB guy do that for us, just because it's a little bit faster in this case. But I would see that animated preview of what's going to happen. So I'm going to go ahead and apply those changes. Of course, I've got a bunch of collisions in the enclosure, but that's just simply because we haven't yet positioned all the components. So I'll go ahead and clear those error markers so you can see it's all coming together. Now I need some help getting the actual component placement and routing done. So
we'll have Danny come in and actually take care of that. First of all, Ben's just going to save this back to the server so that we have published the kind of latest version of this. So all of our collaborators, again, are working with the latest design data. And what Danny's going to do is he's going to come in, he's going to take care of the component placement side of things, make that switch align, and then take care of all of the actual routing of the board as well. So basically wiring everything up. So let's bring Danny in. Hey, Danny, how you doing?
Hey dudes, what's up?
All good here, thank you. Right, so we're going to hand this board over to you. If you could take care of this component placement of the routing side of things, that would be great.
Absolutely. Yeah, we'll take great care of it. All right, let me go ahead and share my screen here. Can you guys see the screen okay?
Yep.
Yep, we're all good.
All right, fantastic. So one of the first things we'll do here is we'll go ahead and grab the project out of here. So there's the USB auth project there that you guys have been working on. So take a look at the routing and the board shape here. Since Matt adjusted the board shape, one of the first things that we'll need to do is we'll actually need to redefine that board shape. Let's see, here's the board in 3D. You can see everything came in just fine here. And we're gonna go ahead and, first of all, and hide the model, at least the top half of it here for right now, so that we can see everything on the board. And it looks like I'll need to reduce the size of the silkscreen referenced as an image too. So getting into 2D here, we'll go into the outline layer and let's get this old outline out of here. And so we'll go ahead and select that, delete that. And then in my design menu, we'll go into board shape and we'll go ahead and create primitives from the board shape. That there, and we want to make sure that we put this not only on the board shape layer, but also on the keep out layer, so that we have a keep out to work on based on our design there. All right, so now that we have that done, we're going to go ahead and get the placement going for these guys. Now we've already designed some memory sticks like this before, so we have a predefined placement. So we'll go ahead and place this from a file that we have in here. There we go, that takes care of the placement. And we'll go ahead and start working on the rest of this as well.
Awesome. So while Danny's placed the parts, we're going to let him go away and continue doing all of the routing and stuff on this board. Now while he does that, I'm going to ask Ben to give us a quick overview of ActiveBomb. So he's going to give you, and he'll hate me for saying this, but can you give an overview in 60 seconds? Now, I know that's not going to do it justice, but we're up against it here on the clock, so I'll leave it to you.
Okay, so ActiveBomb is invoked in Altium Designer by adding a special kind of document called a bomb doc. Don't talk about them on aircraft, okay? And this is essentially a living, breathing parts list, a first-class citizen as a design document, because you're not just designing a physical connection, you're designing a whole product. And the first thing you'll notice is it's grouping everything by like manufacturer part number or library name. And my attention is drawn to the fact that there's some colors here. This amber is like an amber alert. It says not recommended for new design. So we're actually pulling life cycle information for each of these parts from the actual Siva Octopart database. And Lee, wasn't there some news about getting accurate, up-to-date information from the live supply chain?
Yes, indeed. So we're constantly working on improving those sources. And one of the things you'll probably be pleased to hear about is that IHS is now going to also be available as part of that. So not only do we have all of that supply chain data from Octopart with pricing, availability, lifecycle will now be powered also by the kind of industry standard IHS provider there. So again, we're just working constantly to make sure that you've got access to the best information possible through this tool.
Also down the side, along with these textual warnings here, or this one's safe for volume production, we also have this little flag that can change status. Could be information, a green check mark, or it could issue a warning or error. So there's a list of maybe, quite a few different bill of materials rule checks as well to make sure you're not going to generate a bill of materials including parts that are not available or there's not enough in stock for the quantity you want to make, etc. So for this one, just as an example how we'd get around some of these errors and fix problems and scrub it, I'm going to go ahead and add a new part choice list for this component. So this is the current part. It's my 18 PF load caps for the crystal oscillator. And I know for the kinds of designs I'm doing, I don't need to use the exact same manufacturer part, which is of course going end of life. So I'm going to search parametrically. I want 0402 50 volt C0G dielectric, and I get tons of results. Tons of results. And this second one down the list has a clear life cycle status, and there's over 3 million of them in the supply chain available right now. So I'm going to go ahead and add that. So I'm not even using the same manufacturer part number. It could be an equivalent drop-in replacement like this one. And I'm going to rank that as my preferred source, and it's available from a number of different providers here. And now that I've done that, you'll see my warning goes away. I get a green check mark. So I'm ready to generate an actual bill of materials to hand off to the EMS provider.
So you know you can buy the parts, you know you can build the board. All right, let's switch back to Danny and see how he's getting on with our layout and routing side of things.
Oh, dude, that
wow.
looks beautiful.
Actually completed.
All right, yeah. So yeah, I got the reference designators here, kind of put it pretty much into their final spots there. Just a little bit of fine tweaking there. Got all the routes routed. Got some planes in the board here, so you can see inside there. There's ground and power. Everything like that's all set. And
awesome.
so yeah, so essentially we're pretty much good to go there. So I'm going to go ahead and re-enable this top half of this 3D model. Let's go ahead and click on this 3D model and change this to. We'll just leave that a little bit of transparency. You guys can see that in there, and I'll go ahead and save that, and then we'll go ahead and save this project back up to the server.
Awesome.
Looks awesome, bro. Thanks for your help.
So again, same process, very simple thing. Right click, save to server, give it a comment, and away we go.
All right, so I'm going to sign off, guys, and thanks a lot, dudes.
Thank you very much, Danny. So we'll go back to looking at Ben's screen now. Ben is going to pull down the update to this project. Again,
so
really
I
simple to do that.
refresh my version control status here. I can see with the little clock face that the board's obviously been updated. So if I double click on that, I'm going to go ahead and update everything. So it's going to pull all those changes down from the server to my machine. It automatically closes the board and reopens it for me. And there it is, the thing of beauty, all done, ready to go.
Awesome. Okay, so what we've just seen is schematic capture, the MCAD, ECAD collaboration side of things, the PCB layout, and how all of that works within inside the context of Altium 365 and Concord Pro. Now, one of the things I want to do now is just go back to the web interface. So we're going to take a look at this project in here. So if you just refresh this page, Ben, what you'll see is that this is constantly being updated because it has the same source of data that we're working with from Altium Designer. Now, everything you've seen so far has been using Altium Designer to access this workspace. We've been using the authoring tool. But if you don't need to author and you just want to consume data, mark up, comment, that kind of thing, you can use this web browser interface. And it's really powerful to do that. So we're just going to double click on this project to actually go inside it, and you'll see that it'll open up a new tab that's got a very Altium Designer kind of experience, look and feel to it. So we'll have the navigator on the left with the same kind of project structure you would see inside AD. Right-hand side, we've got comments and properties panel. One of the things that we're going to do now is just move on to that USB stick and open this up. So we can view the 2D view of the board. We can control all the layer visibility in here as you can inside AD. We've also got a 3D view of this board as well that we can click on, and we can see the kind of full enclosure and everything that was done. So if we go back to 2D quickly, Ben, we're going to put a quick comment on this board, specifically around that tactile switch, because I know that that was a particular area that this customer was, for some reason, really, really funny about. This had to be in the right place, otherwise, apparently, everything was going to go wrong. So we're just going to put a comment to the effect that we've checked this and it's actually all good, and that should really help him out. So what did that take? I think about 43 minutes, 42 minutes, something like that. So we beat our deadline by a couple of minutes. We're within that 45-minute thing, and so hopefully hopefully our really ambitious customer is going to be.
Do you understand that I have 10,000 plastic things coming from China and that button has to be in the right place? Don't you understand that?
It's okay.
I haven't gotten
Seriously.
an email. I got on an airplane to get out here to review this. I haven't seen anything.
It's really okay. Craig, you've come all of this way. It seems like you've had too much caffeine this morning. What you could have been doing...
I need my job.
I know, but what you could have been doing is following us real time throughout this entire process. Now, you've left your iPad somewhere. If you did have your iPad, then I could have shown you on that.
I left it on the airplane. I was playing solitaire all the way here.
Well, okay. One of the things you could have done is to use the web browser. You know, as we've just shown here, if you'd have signed in via the web browser, you would have basically been able to follow this entire process throughout the whole thing. You know, you told me that the tactile switch button position was critical. We added a comment to that effect, and you could have also commented back on this. So instead of being in the dark as you would have been in the past, you would have been able to see this whole process unfolding in front of your eyes.
So I could have stayed in California and seen this same picture.
Absolutely. I think you've made a bit of a wasted trip here today, buddy, to be honest with you, and I do apologize about that, but you'll know for next time, won't you, when we have to do this kind of thing.
Well, I guess I'm going to have to up my game here.
You certainly will.
Thanks, I appreciate that.
No worries. No worries. So there we have a very happy customer, as you can see. Now there's one other thing I want to actually show you guys today. Can we just cue to 3, please? Three. Ah. I knew there would be one technical glitch today, and it's me having not plugged in my monitor. So there we go. Perfect. Right. So I mentioned at the beginning that, you know, connecting design, supply chain, and manufacture is a really kind of key thing and something we're working towards. You've seen a bit with the active bomb and how we're connecting to the supply chain to get real-time supply chain information. Now, from the manufacturing standpoint, the first step that we're taking is the ability to actually share a lot of the manufacturing data in a much more kind of structured, visual way than is possible today. So I know a lot of people will take manufacturing output, they'll send via email, you know, via a zip file, or they'll put it on a Dropbox or something like that. Now, what we can do instead of doing that is actually communicate this information to the manufacturer by sharing the project. I'm going to show you exactly what that looks like. And it's important to note that when we talk about sharing, we're doing it in such a way where the manufacturer is not becoming part of your team and part of your workspace. They have limited access to kind of your IP and all that kind of stuff. You're only sharing with them the things that they need to actually build that board. So what I'm going to do here, this is one of the projects, this is the one that we just did, that I've actually just shared. And you can send an email link to your manufacturer or to whoever, and that will allow them to come in and get access to this exact same view. Okay, so within this view, we've got all the vital statistics on the board, you know, things like component counts, trace widths, this kind of stuff, previews of the actual product as well. And then on the left-hand side, we can click on this fabrication button. And what you're going to see here is we have a fully capable, fully functional Gerber viewer. Okay? So again, you can come in, you can control the Gerber layer, visibility, all this kind of stuff with inside the tool. And another really cool thing that we can also do is comment in this as well. So again, we can come in, add new comments. And the really powerful thing about this is that we have this concept of now of contextual commenting. So the comment is actually being attached to the part of the design that we're interested in. And I know a lot of people probably have toing and froing via email, and it can be really difficult to preserve that kind of context. So this, again, is something that's really a step forward in helping that. Now, this is just one step. You know, there are many, many more steps that are going to come, but I just wanted to, you know, illustrate to you what's real today, what can be done today, and the direction that we're taking as far as connection to manufacturing goes. Okay, right, can we just bring back on our collaborators, because I just want to thank them for all of their support today in getting this product done. I want to thank our customer as well, Craig, this customer. And I want to thank all of you guys. So, thanks very much, guys.
Thanks, guys. Thanks, Ben. Nice work. So thanks, everybody, for indulging us. We go out of our way, as I've said now multiple times, to not make this a commercial event. We really want you to have this experience for yourselves here at AltiumLive. But I do believe, because we've surveyed and people have requested, they want to see what's coming. So we're happy to give it to you. I will say a couple things first about our collaborators. They absolutely were in those locations. They were in Texas, Boston, and in our San Diego office. And I will just add, this is why I love working in Altium, because we do crazy things like this. And we did that for real. That board was actually routed. That schematic was actually drawn. There was nothing pulled out of the oven pre-baked. They actually did that design in 42 minutes from all these locations. Now, another thing I mentioned last night about the people. So the gentleman from Texas had a baby 24 hours ago. And it's, yeah. And, we practiced this thing late last night. We've been early in the morning, and he has not missed a single one. And I think he actually said, well, can I be a few minutes late? I need to pick my wife up from the hospital. So, this is really the essence of Altium. And the way the analogy I use is, look, I'm into motorcycle racing, well, in my younger days. And I was the fastest second place guy there ever was. I was Mr. Second Place. And the reason I was Mr. Second Place was because it was scary to be in front. I could follow the guy all the way around the track, all the way around the course, absolutely be on his tire the whole way, even pass him every once in a while. The problem is you get in front, then you start looking over your shoulder. And not only do you start looking over your shoulder, but then you have to set the line. You don't know what's around the next corner. You don't know if there's a truck coming around that bend. You don't know if there's a canyon or cliff that you might ride over. And it's hard to be in front, and it's hard to stay in front. And that is absolutely why I love being in Altium, because we do not accept being number one as our end goal. We wanted to be number one only as a way station in becoming transformative to this industry. And we believe that the cloud is absolutely the way we're going to achieve that. Now, Lee is very tight with manufacturing. We came to have Lee with our corporation. We acquired this company called Siva. What has been your experience? What have you heard this week from people, their number one challenge, Lee?
Communication, without a doubt. The kind of the chasm that exists between design and manufacture is just, it's growing, it's widening, it's getting harder for people. Board complexities are increasing, design cycles are reducing. There's more and more information, there's more parts on board, supply chain complexities, all of these kind of things. And so even though we live in kind of a modern internet connected era, we're still kind of very much siloed in many ways. And there's some very bandwidth constrained interfaces that exist between these domains. So it's without a shadow of a doubt an area that we can, and we are being asked to really focus on to improve, to make sure that we close the loop between those two things.
Yeah, absolutely. There's a book I recommend to anybody. It's a great book. It's a very interesting read, it's this book called Alone Together. And this is absolutely the paradigm that we're trying to address. And the cloud is absolutely the way we're going to achieve it. Now, look, if you can't use cloud because you have a military restriction or things of that nature, these products are available on premise. But absolutely, this ease and this convenience of the cloud is something we're going to lead the way in, and it's actually absolutely available for you guys to try. When we say what you saw was real, that included the request. You literally just go to our webpage, click try, and you can have that experience yourself for free for 30 days. So with that, Lee, unless you have any closing comments, we can end the keynote and we can send them on to a short break. We're about 5 minutes behind schedule, and then off to your breakouts.
I'm all good. Just want to say thank you very much for attending and for watching that today. I hope you enjoyed it.
Thank you very much, everybody.